In version 4.1 of the 3D.js render add-on by KIRI Engine, we introduced a new autocrop object generation feature for quickly isolating the main subject of a Gaussian splatting scan. In this video, I'll show you how to use the feature to turn this full scan into this refined human capture without any manual editing. Okay, here in Blender, I'm going to press the N key on my keyboard to open the N panel and find the 3D.js render add-on. And from the Edit menu and Import submenu, I'm going to import a new PLY file as verts, and I don't care about rendering, so I'm not going to create a proxy object. Import PLY, find my PLY file, there it is, and import. And immediately after importing, camera updates are disabled. I could enable them, but for editing, I'm just going to show as a point cloud. And in rendered or material preview, I can see the colors. And I can see it's the wrong alignment for Blender, so I'm going to select my object and hit rotate active to Blender axes. And that's much better. Now this is a massive scan. We have a full sphere of background points here. We've captured a lot of the surrounding room. And in the center, we have our human figure, and this is the only thing I'm interested in right now. Okay, with my scan selected, I'm going to, in the edit mode, jump into the modifiers submenu and find from the list the crop box modifier, and I can add this with the plus icon. And I can see in my modifier stack that a geometry nodes modifier has been added at the top of the stack called 3D.js crop box. And at the top of the crop box menu, we have auto generate crop box object. If I hit this, a new menu will appear. This function works by finding how close together points are to their neighbors. So points on, let's say, the face of this figure here are very dense, very close together. They're more likely to be preserved. And we can see these points in the background that are much more sparse are more likely to be culled. The mode, quick, gentle, and aggressive are a number of presets that change some settings under the hood, but 90% of the time I stick with quick. The filter epsilon is the one setting that I might change for each scan that I use. This figure is relative to the size of your scan, so some scans might have a background sphere of points and be absolutely massive. Some scans might be only the interior rooms and walls here, and some scans might already be a relatively isolated object. So depending on the scan, you will need to change the filter epsilon value. Filter min points, I don't touch 90% of the time. This is the minimum number of points that need to be within a cluster, a determined cluster of points to be considered for keeping. So if we find 10 points within a cluster, we'll keep them. If we find less than 10 points, we'll get rid of them. And you can change this value if you want to do some advanced editing, but I hardly ever touch this. Filter fast mode will attempt to speed up the processing, but 90% of the time, again, I don't use this. And create convex hull object we'll show in a minute. For now, I'm going to stick with all the default values. Press OK and see what that gives us. Processing is finished, and I can see that she's now wearing a nice little hat, which is not exactly what we want. So I'm going to remove this. And what we need more points. We removed too many points. So in my auto generate crop object settings, if we want more points to be kept, we increase the filter epsilon. There's not necessarily a known good value for a particular scan, so I'm just going to pump it up to, let's say, 0.09. The more points that are kept, processing may take a little longer, so sometimes you might only want to increase it a little bit, but I've already tried this scan before and 0.08, 0.09 seems good. And press OK, and wait again for processing. And processing is complete. And this is looking much better. I might have been able to keep perhaps more of the shirt here, if I'd put the filter epsilon a bit higher, but I'm going to say that that's okay. So now we have two objects. We have our original 3D.js scan here, and we have our new autocrop object that has no modifiers and is purely composed of points. If I select my original object again, and I look at the crop box modifier, I can specify crop by object and select my newly generated object and set the mode to nearest point further than. I can see that something's happened already, and I have a distance here of 1. What happens if I change this? I can see that the original scan is looking for the closest point in the new object, and if the distance to the closest point in the new object is further than this value here, a point will be removed. So if I enter 0, points have to be exactly on top of the newly created object, and I can dial in and control the culling using this value. I don't need to have the crop object visible in the viewport, so I'll actually hide this while I'm working. And to get a better view of what's going on, I'm going to stop showing as a point cloud, enable camera updates, and update the view. And I can see crop box off and crop box on. And if I'm happy with the results, I can apply the modifier with the tick here. In the auto-generate crop object settings, we also saw create convex hull object. Let's try again using higher filter epsilon settings and enabling create convex hull object and hitting OK. This time we first removed the background points as we did in the first version, but the remaining points have been turned into a convex hull object that we can see here. I'm just going to call this convex hull so it's easy to find and hide it. And again, in my original object's crop box modifier, I can specify convex hull as the crop object, and I can remove anything inside this crop box or everything outside this crop box. Or I could remove points by their distance to the mesh surface of the crop box. In most cases, I would leave create convex hull object disabled, but it can sometimes be useful and a little faster to process than the nearest point's distance. Once the cropping has been performed and applied, you're safe to export this object to external 3D.js viewers or to render it within Blender.